What if I told you that the same basic principle that decides a coin toss also explains, well, life itself? And not just life, but the very structure of our societies. Today, we're going to dive into a really powerful idea that connects physics, biology, and even culture in a way you probably never saw coming.
So yeah, a coin toss, a living cell, and human society. What on earth is the link? It sounds like a riddle, right? But the answer is this deep, fascinating connection between information, order, and energy. And we're about to unpack it all.
Here's how we'll do it. We're going to start super simple, with the odds of a coin flip. Then, we'll see how that connects to the energy that actually powers life. From there, we'll figure out what really separates life from non-life, and then, this is the cool part, we'll scale that idea all the way up to human culture, before we wrap up with a totally new way to think about the health of our communities.
All right, first things first. To really understand something complex, you've got to get a solid grip on its total opposite, pure random uncertainty.
We throw around phrases like 1 in a million all the time, but what does that actually feel like? It's a number so big it's almost impossible for our brains to really grasp. But there's a surprisingly simple way to visualize it.
That's it. A 1 in a million chance is the same as taking a coin, flipping it 20 times, and having it land on heads every single time. Just try to imagine actually doing that. Suddenly, 1 in a million feels a lot less likely, doesn't it? This gives us a real gut-level sense of just how improbable that is.
Now, this whole idea was officially nailed down by the physicist Ludwig Boltzmann, and his famous equation here, don't let it scare you, it's really just a fancy way of counting. W is just the total number of ways something can possibly turn out, like all the possible heads or tails combinations of those 20 coin flips. The more possibilities, the more W grows, and the higher the uncertainty, which physicists have a special name for, entropy.
Okay, but what happens when the outcomes aren't totally random? When some choices are more likely than others? This is where it gets really interesting, because information stops being just some abstract thing and starts acting like something tangible, something with real power.
So we need to kind of level up our thinking from just uncertainty to this other concept called net surprisal. It's the difference between knowing a die has 6 sides and knowing the die is weighted to land on 6 more often. That little gap, the space between pure random chance and what you can actually predict, that's not just data. That is information that has real value.
And now for the big one, the core idea that connects everything we're talking about today. This net surprisal isn't just a thought experiment. It has a real physical meaning. In physics, it directly maps to the amount of ordered energy that's available to do actual work. I mean, think about that for a second. Having useful ordered information is the physical equivalent of having a battery pack of potential energy. Information is power, literally. Okay, so if useful information is basically available energy, how does the universe actually use that energy to build complex, ordered things like you and me out of all the background chaos?
Let's start with a really simple physical example. Take a piece of glass. Its molecules are all jumbled up, disordered. If you look at it, it seems the same from any direction. It's symmetrical. But when those same molecules organize themselves into a quartz crystal with that perfect lattice structure, that symmetry is suddenly broken. It now has very specific angles and faces. This broken symmetry is the telltale sign of order and complexity. Now let's take that exact same logic and apply it to life itself. Because a living cell, it performs the ultimate symmetry break. By creating a boundary, its membrane, it creates a definite inside that's incredibly ordered and an outside that's chaotic. This simple distinction between in and out is the fundamental broken symmetry that makes all of life possible.
But here's the thing. This incredibly powerful idea of an in-out boundary doesn't just stop with one single cell. Oh no. Life uses this same trick to build on itself, creating these nested layers of ever-increasing complexity.
You see how life builds on itself? First you have the cell membrane. Then you have the skin of a multicelled organism, which is another boundary. Then you zoom out again, and you have the boundary of a gene pool, the thing that separates one family from another. And for us humans, there's another layer, the boundary of an idea pool, which we just call culture. Each one is a new, more complex layer of life.
And this leads to a truly radical thought. If these higher layers, like a gene pool or an idea pool, have boundaries and exist as their own things, does natural selection act on them too, not just on the individual organism? Well, the answer seems to be yes. This is a pretty intense example, but it makes the point perfectly. This grizzly's terrible behavior doesn't help the survival of the grizzly species at all, but it makes perfect sense for the survival of his specific family line, his gene pool. It's as if the gene pool itself is a kind of life form, and it's using the bear as a vehicle to compete against other gene pools. That's natural selection working at a whole other level.
And that brings us to the absolutely crucial question for us. If a collection of genes can clump together and form a life form that competes for its own survival, can a collection of ideas do the exact same thing?
And it really seems like they can. A collection of ideas, a culture, a movement, an ideology can act just like its own life form. It can become aggressive and compete with other cultures, sometimes in ways that don't even really benefit the individual people who are part of it. So from this point of view, when we talk about culture wars, we might be describing something far more literal than we realize, the clash of competing idea-based life forms.
Okay, so if we're all part of these nested layers of life, from our own bodies to our families to our cultures, how in the world can we measure the health of the entire system? Well, this whole framework gives us a brand new way to look at it. We can actually map our lives onto these different layers. For our individual organism, skin in is our personal health, our fitness. Skin out is our friendships and mentors. At the next level up, gene pool in is our immediate family. Gene pool out is our wider community, our politics. And finally, idea pool in is our internal culture, our traditions, while idea pool out is how we engage with the wider world through our jobs, through science. A truly healthy community, you see, has to support all 6 of these layers.
And this number, this right here, brilliantly shows why we need each other. Research suggests that on average, any one person is only likely to really excel in about 4, maybe 4 1/4 of these 6 essential layers. Nobody, and I mean nobody, can do it all. This shows in black and white how we fundamentally need each other and strong communities to keep the whole system healthy and thriving.
So, I'll leave you with this thought. When we try to measure the success of our society, we usually focus on things like the economy or maybe individual happiness. But if this framework is right, are we completely overlooking the health of these other, very real layers of life? Our families, our local communities, our cultures. What would change if we actually started measuring that?